All right, we're going to go ahead and graph this reciprocal function. And I can tell this is a reciprocal function because when I look at this, I see a rational value, which means it's a fraction. And you'll notice that the x is actually down here in the denominator of the function. And that way I know it is a rational value. Okay, so this is the rational function. And hiding in here are all sorts of transformations. I can see that there is a vertical stretch up here. I can see that there is a vertical translation down. I can see that this 1/2 is in front of the x, and that looks like it's going to turn out to be a horizontal stretch. And then this plus 2, well, it looks like it's going to obviously apply to the horizontal as well. And left or right, well, not quite sure yet, because we need to do a little bit of work down here in the bottom first. When we look at the reciprocal function, we notice that the x has a value glued to the front of it. And so we need to make sure that there is no value glued to the front of that x. So to start with, I'm just going to rewrite this, and we're going to manipulate the equation just a little bit. I'm going to take that 1/2 and I'm going to factor it out. So when I factor it out of both terms, because notice that both terms are in the denominator of this rational value. So 1/2 factors out and I'm left with x, and then 2, positive 2, divided by 1/2 is positive 4. Okay, still have the negative 1 or the subtract 1 at the end. All right, well, what do we do now? Well, we learned that we can take and combine this 1/2 that I just factored out with the 3 on the top. And if I rewrite this, I'm just going to combine them together. I'm going to say, okay, that is 3 divided by 1/2 times 1 over, and now I've just got the x plus 4 all by itself minus 1. I know that 3 divided by 1/2 is equal to 6. So I've got 6 times 1 over x plus 4 minus 1. And now I'm ready to sketch this because all of the different transformations are easily identifiable here. Now, let me just take you back to this step here for just a minute. Notice that we've got this 1/2 factored out in front of the x plus 4. And because it's associated with the x in the denominator, we could clearly see that, okay, that is going to be a horizontal stretch. And I could leave it and apply, the horizontal stretch separately. But it just is so much easier if you take this 1/2, combine it with the vertical stretch here, and reduce it to just a single value. Okay? All right. Well, what have we got here? Well, it looks like this 6 here is going to be a vertical stretch of 6. The positive 4, well, remember, if it's associated with the x, it's the opposite of what it appears as. So we normally assume that positive 4 would mean move to the right. This is going to be a translation left of 4 because this is expected to be x minus, and then negative 4 would be the p-value. The minus 1 at the end, well, again, that's going to be a vertical translation down of 1. And that's it. Okay, well, how do we get started? Well, first thing I want to do is just remember what the original parent function looked like. And the parent function of a hyperbola, which is the reciprocal function, it has an asymptote, and the asymptote is right along the y-axis, as a vertical asymptote there, and it has a horizontal asymptote like that. Okay, and I want you to think of this sort of center point, or this anchor point right there where the two asymptotes cross, is kind of like a bullseye, because it's important that we realize that where that point is, because the typical hyperbola is over 1 and up 1, and right there is where, and down 1 is where we're going to find the regular function. So if I was to sketch the hyperbola, it would go through that point, and it would start up there, touch that point, and then curve this way and carry on forever. And this one would come up through this point, curve, and then carry on forever in that direction, never reaching or never actually touching the two asymptotes. Okay, well, what about this translated function? Well, how do we find where that is? Well, the first thing we're going to do is we're going to find out where these two asymptotes are. So if I was to go hunting for the asymptotes, I know they're going to be controlled by these red transformations, because those up and down and left right are going to move the asymptotes. So let's go ahead and do that. Let's just get rid of that. Actually, we'll just get rid of those points, and then we'll go ahead and we'll start working on our new function here. So let's put in the new asymptotes. So the new asymptotes are going to be, well, the horizontal translation is to the left 4, so I'm going to go over to -4, and I'm going to put in the vertical asymptote right at -4. Okay, there's another asymptote, and that is at -1 because we have moved down 1, so we'll put in the other asymptote right there at -1. By doing that, I have now created a new bullseye, if you like, a reference point right there. Okay, right at the intersection of those two asymptotes. That means that the points that would normally show up over 1 and up 1, that would be right there, are not going to be there anymore, because this vertical stretch of 6 is going to affect that. Okay, so normally we would go over 1 in the x direction and up 1 in the y direction, and would put a dot right there. Well, that's changed a little bit. This 6 has stretched the y direction. So instead of going over 1 and up 1, we're going to go over 1 and up 1, 2, 3, 4, 5, and 6. And that's where that point is going to be. Okay? Now on the parent function, remember the parent function is 1 over x. When x was 2, 1, 2, 1 over 2 is 1/2, we would only go up 1/2 right there. So we'd have a vertical movement of 1/2. Well, in this case, it has stretched the vertical movement by a factor of 6. So that means that the over 1, or over 2 rather, and then up 1/2 is now over 2 and up 1/2, 2/2, 3/2, 4/2, 5/2, 6/2. So we're going to go up 3 full squares from there. So 1, 2, and 3, right there. Okay? So that has started to reveal the shape of this hyperbola. We know that it's going to be up here, and it's going to start sort of off the grid there. It's going to come down, pass through that point, pass through this point, and then curve off this way. So you can see that that vertical stretch of 6 has pulled it up and away from the x-axis. All right, well, how about the lower arm over here and to the left? How do we do that one? Well, we do it the exact same way. We know that it used to be over 1 and down 1 in the y direction, but that isn't happening anymore. It is going over 1, but it's going to go down 6 because of the vertical stretch. So over 1 and down 1, 2, 3, 4, 5, 6, and put a dot. Similarly, over 2, it used to be over 2, down 1/2. Now it's going to be over 2 and down 3. 1, 2, 3, put a dot, and then we can go ahead and draw a fairly smooth curve. It will start out here somewhere, come up through here, and then carry on in that direction. Okay, so when you are graphing the reciprocal function, well, the first thing you need to remember is you're going to ensure that the x variable, so right there, does not have any value associated right in front of it. And if there is a value there, you must factor it out and encase the x and its horizontal translation in brackets. Once you've done that, take that, in this case it would have been a horizontal stretch, and combine it with the vertical movement. And that makes life so much easier, because then you're just dealing with one vertical stretch or compression, and you only have sort of 3 values to work with. Okay, before you graph anything, you move those asymptotes. They go from 0, 0, the x and the y-axis, and you get a new reference point, which is going to be based on those little red transformations. Get those, and then plot a couple of points, and you're away to the races. Okay,